we live? We may be live. Hello, hello, hello. Welcome to another new old computer stream. Thank you for tuning in and for watching. Always appreciates everybody's feedback and comments and discussion. Makes the whole thing worthwhile. I should probably put on this microphone. I don't know how much of a difference this crappy microphone makes. Oh, hi Brenda, thanks for joining. But from previous experience, I remember the reason I got these microphones was because of the fume extractor that I use when soldering. Without an extractor, the air gets pretty bad pretty quickly around the soldering station. So it's better than nothing. Yeah, exactly. The mic is probably a good idea. The option, yeah, great minds think alike. And the other microphone I have is on the webcam here. It's like a mid-range Logitech webcam that I've been using for a while. I have one more over here. And it's decent, but yeah, it's pretty far away from me when things are happening over here. So the audio was pretty the fume extractor audio was pretty overpowering. Actually, let me close the closet door behind me there. There. I think that makes for a little cleaner background. Looks okay, right? The background right now is a few compact Macs here. We have a 2GS sitting up here. We have a magneto-optical disk drive sitting here. Yes, today's topic will be Lisa. Before I go into that, I like to just do a quick recap for if anybody watches these streams in chronological order. Last time I was playing with a Performa 6116 CD with a DOS compatibility card, 486 66 megahertz 486DX4 on a card, and we did pretty well. The machine works. It sits actually, yeah, it's over there. It's in parts again. But where we left off last time, I was trying to make DOS 6 floppy disks to install an operating system. I guess one of the drawbacks of that machine is that the floppy drive is kind of the main interface to get files onto the PC system hard drive before you set up the whole Mac integration with file sharing and stuff. So you're kind of tied to the, as far as I know, tied to the floppy drive. And it was kind of flaky. Memtest x86 was failing. I was getting read errors, and also I was flailing around trying to make new DOS floppies from WinRoll PC. I figured that out eventually. I just needed to use the right program, namely Rollwrite for Windows is what I'm using. It's a very nice piece of open source software. It's very old, but it still works. So Rollwrite, in one word, is a great program if you want to write floppy disk binary images from images on a PC to I have a USB floppy drive that I used last time, which is super handy if you figure out the driver situation. And so yeah, but with fresh DOS floppies, I was still having issues. I was still getting kind of flaky read errors, and I ended up recapping the logic board, and that solved the problem. So yeah, crappy caps on the logic board was causing the bus to break down somehow. So there you go. Even though I couldn't see a single sign of leakage on, I was pulling off all the caps, this surface mount electrolytics, and they all look pristine. There wasn't any sign of cap juice. Even when I was putting a lot of heat and soldering and crap on the board, I didn't get any of the fishy smell, which is very distinctive. I know because my wife complains every time there's any fishy smell coming from this room. But yeah, it just goes to show that even like the mid-90s Power Macs Probably needs preemptive recapping at this point, with those typical surface mount round sort of cylinder shaped little guys. So I was able to get DOS on the machine. I was able to get Windows 3.11 on the machine. It's working pretty great, except I am not getting audio out from the Sound Blaster Vibra daughter board, and I'm not getting the CD-ROM integration to work. The CD-ROM keeps getting captured by the Mac OS, not by not by DOS. But otherwise, it's a very functional PC in a Power Mac. Super nice. It runs hot, but it seems to be doing well. But yeah, I'm gonna try and tinker with it a little bit more, see if I can get the Sound Blaster audio out to work. But yeah, so that was just a recap from last time. If anybody was interested, I'll probably show that machine on the channel again someday maybe. But yeah, so without further ado, let's jump into today's topic, which is an Apple Lisa, which sits just next to me here. It belongs to my friend Eli. It's been sitting in my workshop, my office, for it's almost 2 years now. I did some initial repair work on it, was able to do some repairs on the power supply. I was able to do some of the I/O board and motherboard were pretty badly battery damaged, fortunately. So they needed a lot of trace repairs and stuff like that. And it worked fine for a couple of weeks, and then it started deteriorating again. So I was asking around on the Lisa list and trying to get advice from actually not knowledgeable people, and they advised that there may be something with the MMU, something with the bus getting clogged, or not the data not coming through quickly enough between the I/O and the MMU, memory management unit on the Lisa, so yeah, I kind of got stuck there. It's hard to work in Lisa because of how it's designed. So what I want to try to do is the brute force approach of building brand new I/O boards and motherboards for this thing, because that eliminates any trace problem or via problem. As a beside, it was interesting that one of the problems I was having was that the vias, the little, for those who don't know, the vias are the little copper holes that go through to like a multi-layered board and provides continuity, kind of a trace going, or electric signal going through the board. And battery or any kind of corrosion, battery or capacitor corrosion, or any kind of moisture corrosion, can cause those vias to get oxidized and crusty, and that introduces a bunch of resistance potentially into that via, and that resistance, or maybe it gets just fully disconnected, and those are really hard to find, those bad vias, but I was lucky after poking around a lot with my multimeter to find, I think it was 2 vias where corrosion had introduced a couple of 100 ohms of resistance, and that threw off the whole computer and it wouldn't start properly. So I'm just super suspicious that there are other crappy vias or traces that are not fully good on this, and I've also read people who have fixed Lisas with similar problems. There are potential that some logic chips have gone bad or are marginal. So yeah, I'm gonna try the brute force approach of building new boards for this. I'm gonna reuse some components, but I have mostly sourced new components. Anyways, so I think I want to show off. I have my nice camera sitting over here. Let's see if I can get a shot of the Lisa. Let's see if I can turn on the camera. Let's switch over to video mode and something like this perhaps. Alright, I think I have a decent shot at the Lisa now, so let's see if we can... okay, that's not working. Here we go. So here's the Lisa. In live, she's live. It's pretty dark in here. Maybe if I do this to the lights. Yeah, I don't know. Like this. So yeah, you can see Lisa's in here. Double audio. Let me... maybe like that. Oh yeah, it's because yeah, the camera. Yeah, you're right. The microphone on this camera kicked in. Thanks for that. Brandon always mindful about the quality of my feed. So yeah, we have the Lisa. We have the mouse here. We have the keyboard. I've done a ugly bodge here. This was unfortunately damaged, so I just had to bodge the keyboard cord. We have all the software sitting over here. We have MacWorks Excel, and we have all the documentation and the floppy disks for the Lisa software. So this should potentially be an amazing workstation in 1983, right? It can do anything. You can do word processing and spreadsheets, and you can click on buttons and pull on... oh, sorry, it's really dusty. I haven't touched this for a while. Sorry, Lisa. Yeah, this is the original mouse. It's a weird angled design. Good condition otherwise. Model number A9M0050. Serial number 000326. So I don't know if that means that it's probably not probably not mouse number 326. I mean, it could be. I don't know. So if somebody's knowledgeable about Lisa hardware, maybe it's a super early mouse, but it can also be number 326 on the 4th of February 1982 or something. I don't know. And yeah, the keyboard here. It's a full numpad enabled. Dust, sorry. And it has foam and foil. Yep. So I had to replace the original foam and foil pads on this because they were completely dead. They deteriorate with age. So I just got replacements from Texelec. It's a bit of an annoying job, but it's something that you just have to do. So there is the back of the keyboard. It has like this weird, I don't know what to call this, like mounting thing. I don't know what you did with that. This plastic thing here comes off. All 4 feet are intact. It's the same feet as on the Apple II, I think. Maybe a little bit different angle. Yeah. My friend got this machine very early, sometime in the 90s. I think he bought it from somebody who was running a BBS on it in the late 80s, if I understand correctly. So he's been in possession of this machine for some 30 years. And yeah, nothing else really to say. Of course, it doesn't have any command or... oh, it has a command. Oh, it actually has a command key. Yeah, command sits here. The caps lock latches, which is nice. But yeah, otherwise it's kind of like a really bare bones. Like it doesn't have too much design flares as a keyboard, right? Except for this sort of wedge here and the Apple logo. It's kind of anonymous in my opinion. It's kind of stark, right? It's very angular design. I will demonstrate what's wrong with this machine in a moment. Oh, actually, I want to show this. This keyboard connector is so chunky. Oops, I turned on the machine. Sorry. Yeah, I jumped the gun on that. Yeah. So anyway, I jumped the gun on turning on the machine. Here's the machine. It's running its self-tests. And as I was unplugging the... There we go. I'll turn it on off again. So I'm gonna redo that in a moment. But anyway, it boots to this degree. But before we go into that, I'm just gonna show off the floppy disks. So first of all, we have the Lisa software here, so all the labels are kind of coming off. All the glue is gone basically. But we have all the Lisa system disks and software disks here. These require the hard drive, which this machine lost a long time ago. This is a Lisa 2.5, I think, originally, or 10. I don't remember. But the what's it called again? I forgot the name. Profile, right? The Lisa Profile hard drive that's supposed to sit on top here is long gone. And without that hard drive, this Lisa software doesn't really work. So we're not gonna test that. We will run MacWorks Excel, however, which is sort of the wrapper software, the emulation for Macintosh software. Excuse me. Oh yes, MK500 asks, so some Lisas had 5.25 inch discs and some 3.5. So this is a later, yes, so the 5.25 inch Lisas are called the Twiggy Lisas. They have two chunky 5.25 inch floppy drives here, and they have a very different styling with like an embossed Apple logo and like Lisa written in a cursive fonts and stuff like that. They are very rare and very desirable these days. And in fact, many were converted into the later Lisa 2 just because, well, I think somebody can probably tell the Lisa story better than I, but the Twiggy drives were just unreliable and weren't really future, how to say, future compatible. The 3.5 inch drives were just faster, more reliable, more storage. Sony, Apple had a good deal with Sony to produce these drives, so they just rejigged the Lisa line to use 3.5 inch drives. But it's interesting. When you open up this machine, you can clearly see that this compartment behind this bezel here, the front here, is very much designed to house two 5.25 inch floppy drives, right? And when you just have this one 3.5 inch floppy drive, it's kind of like a lot of wasted space here. So it's very much a hack that Apple did late. Anyways, so back to MacWorks Excel. So this is what I use for testing because it just demonstrates very easily what's going wrong. So we have some documentation here. We have Steve Jobs on the Macworld cover. It says, Macintosh, Apple's remarkable new personal computer. Yeah, it basically says that your Lisa can run Macintosh software. Yeah, you're welcome. I'm glad I can educate you and anybody watching. So some floppies sitting in here. So I think what we want to use is the no, this is the system disk. This contains system software 4.3 maybe? I don't remember. But I think what we need to start with this MacWorks Excel disk, which is the wrapper boot software that puts it into the Macintosh mode. Oh cool, you have a signed copy of the Steve Jobs magazine. That's amazing. The Apple Store opening. Where is that? The Apple Store opening in San Francisco or somewhere else? So anyways, the glue is coming off on all these labels, and I by the way, I did look into potentially, how can we glue this back on, but any method that I could really think of would be somehow destructive and maybe cause problems in the future and kind of ruining the label or whatever. So they're kind of floating around. So I just take them off for operation. So let's turn on the machine again. Let's do this. So there's a big chunky power button here. So let's turn on the machine again. This time the keyboard is connected, so we should avoid the keyboard error. So CRT is slowly coming on. It's testing the CPU card, it's testing the memory boards, testing the I/O board. Then it beeps very loudly when it doesn't find the boot drive. So you insert the disk, and then the very loud 400K disk drive spins up, and then you do Command 2 to continue. And that should start booting MacWorks Excel. And this basically, I think, emulates, there we go, so SAD-Mac, that's what happens. So what it's trying to do is just emulate the Mac ROM and the APIs, yeah, it runs, I think, I looked up the code, it says OF000A, which is some kind of bus error, I believe. So this is what we're dealing with. It used to work. I used to be able to boot into MacWorks Excel. Yeah, it's a boot camp of the 80s. Yeah, no SAD-Mac sound. And I don't know if this comes through in my microphone, but the power supply in this machine is very loud. It has a very high-pitched whine to it, and I think that was, I've heard that they were pretty noisy. This is the stock Apple power supply. I have a later generation Sun remarketing power supply. It doesn't work, but yeah, this is known to be a noisy power supply. And I have a floppy EMU as well. The Lisa works well with the floppy EMU. You can load Lisa software, you can load MacWorks Excel and Mac software. So I tried all different sorts of software. There is a diagnostic software that I can use, but it throws other kinds of errors. It has I can also try to boot AUX, like the Microsoft-owned Unix for the Lisa, and it throws other kinds of errors. So it's just the bus gets messed up when it's trying to load data into memory from the I/O here. So hopefully we can figure out, or rather we can fix it brute force by just building new boards for this one. Let's see. Yeah, unfortunately when the system crashes, it no longer turns off with the power button. And by the way, this is an incandescent lamp, I think. This is a lamp, not an LED. So it kind of gets hot to the touch with operation, which is kind of funny. So you have to somehow, I think the easiest way to turn it off is just to pull the back cover off, because that triggers a switch, like a safety switch that prevents you from running the computer without the case. So let's just do that. I'm just gonna Interesting. There we go. Now turn off. So yeah, that cover comes up. So this is the older Apple logo design in like a square box. What would you call that? Rectangle, square. I believe the Twiggy Lisa front has an Apple logo of this style rather than kind of the more modern design. See if I remember how this comes off. I'm just going to demonstrate. Here we go. The front comes off. MK500 says, I'm following several people building new Lisas based on those new boards from Mastodon. It's very exciting that this possibility. Yes, exactly. That's what I'm going to attempt as well. I got inspired reading about those stories. So here you can see what I was talking about. There's this huge empty space here where a 5 1/4 inch drive can be mounted. So, but now we just have this teeny floppy drive. This is actually 400K, an early 400K drive. So it's chunky compared to the later compact Mac drives. And then we have a little driver board here, but that's basically it, and just some ribbon cables. Let's unplug the keyboard. Put it inside. Let's put the mouse aside. It's probably a very valuable mouse. Turn it around. There we go. So here's the early Apple power supply for these. Part number 620-6103. It works all right. I think all the voltages are fine on this one. Yeah, it's kind of a complex design. It was a pain to work on. I'm not very good at power supplies to start with, but I was able to fix it by trial and error, basically. And it comes out like this. The Lisa is just entirely modular in design, which is pretty cool, I think. And sort of the front of the machine sits in this card cage here. It slides out. And it's connected to the rest of the machine with these two edge connectors. Edge slots. The one on the right hand side is for the analog board and the CRT, and the one on the other side is for I/O, basically, I think. Could be wrong. You have the I/O board sitting out here, and then behind it sits the CPU board, and then we have two memory boards, just tons of memory chips, and then 3 expansion slots on the side, and then the 2 edge connectors that plugs the heart of the computer into the I/O and display. So to work in this machine, you have to pull this apart, basically. So the memory boards come out like so. Yeah, it is really easy to work on. The only drawback is that in its default configuration, it's really hard to troubleshoot the machine when it's running, right? Because there are these layers of boards and it's all inside of this case. It's not like an Apple II where you just have all the circuits you just let in front of you when it's on, right? So the way that you work on these is you have these riser boards, I think, where you can put them on an angle or outside somehow while they're running. So let's put these two, I think still works. I've done some cross-testing to just make sure. I'm pretty sure these two memory boards work fine. And the CPU board. We have the Motorola 68000 over here, the heart of the machine. Very powerful processor for its time, right? Some ROM chips and just a bunch of logic. Nothing on the back. Let's put that over here. So the trouble children here, the I/O board, because there used to be a big battery here for the clock, they leak. They cause a lot of trouble and heartache for Lisa owners. So I did a whole bunch of repairs over here. I'm going to try and show it on the bench, but there's a bodge here, and there's a lot of traces that had to clean up, and there's some caps in the resistor in this area had to be replaced. And as I said, it worked for a while, but then it didn't. So some of the LS logic chips here may be failing. Maybe some of the traces kept getting, there's some VS that were continuously corroding. Something's going on here, right? Probably not in this area. This is the most valuable chip on here. It's the COP chip, C-O-P. These are bespoke and made, I think, custom for Apple, if I'm not mistaken, by who was it? I forgot the manufacturer, the OEM. But yeah, anyway. So this is the one that I want to rebuild. But I want to rebuild the motherboard first. So this is what Apple called a motherboard. Even says right here, it's hard to see in the camera, but unlike IBM, who like to call the logic board the motherboard, right? Apple calls this interconnection board the motherboard, but it's pretty much just a bunch of passives, one LS chip, logic chip here, some resistors, a big cap, but not much going on this board. But since it sits just underneath the I/O board, the battery acid or base juice trickles down onto the board right here and causes damage. So I had to replace a bunch of the resistors and caps and fix up the traces that were broken. There's some bodges on the underside. You see 2 bodges here that are still attached, luckily. And so in order to work on the motherboard, you need to unscrew a bunch of screws, and I think I left most of the screws out. But I think I need to do a little bit more screwing to get this out again completely. Yeah, so normally there's like 12 screws here or something. But I don't think I only put in 1 as I was working on it. Let's see. I need to find my screw. I have this compartmentalized storage thing. I have all the Lisa screws in one of them. And let's see here. There might be one more. Oh yeah, there's one more screw here. So I think, I mean, it's a beautiful design, and it's like theoretically, I love how modular it is. It's super cool. But yeah, it does make it a bit more complex and annoying to work with. Okay, so this bracket comes off. Put that aside. Focus is locked. Okay. Yeah. Did I? Let me see what kind of I do have autofocus turned on, but I guess this camera is just aggressive at focusing on whatever is in the middle of the scene. So you're asking how many boards I will replace. The answer is 2. But actually, it's 3. I will explain in a moment. Oh, one more screw. Okay. See if I can get this out. There may be one more screw somewhere. Oh, there it is. So yeah, once I will start working on the boards proper, I will move to the camera over there. There we go. Now the motherboard is loose. You can see that here is what a bunch of battery damage kind of just did away with the steel, whatever it's called. That's the stainless surface of the steel. So I had to. This is pretty ugly. I mean, somebody can probably galvanize the surface again, but I just put some rust converter paint on top to stop the corrosion. I sanded it down and then yeah, just put some paint on top to keep it from getting worse. And this is always well, apart from this, here are the IU labels, so I was careful not to get any paint on these labels. Reset video out, parallel mouse, serial A, serial B. But yeah, that's why it's kind of black here. So this is the motherboard. This goes like in this direction. So yeah, we have 2 large edge connectors here for the CPU board and the IO board, and you can see this is the IO board's connector is green. That's because this is a new one. I have replaced this entirely because it was just complete, like some of these tabs here, some of the connectors were just gone. It's just eaten away, and others were pretty green from corrosion. So yeah, it was a mess. There's also some corrosion on the edge connector here. Some of the copper has been flaked, especially on the underside. There's like a copper has been flaking off here. It's all black and nasty. I think it's still fine, making fine connection, but this is one reason why it's best to get a new PCB for this, because this copper is not gonna get any better. 2 bodges here that I put on because the traces here were eaten away, and I think these are just the serial port circuitry here, so it's not mission critical, but you know, still you want serial for network local talk or whatnot. We have a video out for composites if you want composite video. You have a little switch here, reset switch, and you have these 3 expansion slots, which I think these 3 are pretty proprietary. I don't think these can be replaced, so I'd have to transfer those over, I think, to get back to get expansion cards. So to answer the question, I will rebuild the motherboard, I will rebuild the IO board, And later on, I will rebuild the power supply. So I'm not gonna open this up today, but it's, as I mentioned, it's kind of a complex design using proprietary parts that are not made anymore. So when this supply dies, yeah, you need a different way of getting power. So to achieve this, here are the replacement boards. So this is the Lease ATX. So this is a ATX based, you put a standard power supply on here and a daughter supporting power supply and some components, and then you get a power supply for your Lisa, which is future proof. It's the motherboard replacement. I think it has a very distinct outline, so you can see where this goes. Then we have the I/O board with all its chips. So the way I was thinking about this is the motherboard is clearly the easier thing to do. I'm 99% or 98% sure that it's not the motherboard that's the problem. But it's still the easier thing to start with, so that's what I'm planning to do. And I don't think, we'll see how long I can last, but this is probably there's so many components to put on this one, so it will take a little while. So I'll put these to the side for now. And I still have the Mac Excel software in front of me, so I'll put those away. And Lisa mouse. Let's put it over here. I'll turn off the camera to save the battery. So let's focus on the motherboard. I'll put it there. Let's check the bench camera, what we get. So I'm always struggling. So it's not a great bench camera. I always feel bad about this. Let's see if I can resize myself. Don't mean to be that big. Like that. Just a moment. So yeah, sorry for the messy focus and for the not so sharp picture, but at least this time we will work on pretty large chunky components, so I think it will at least illustrate more or less what I'm trying to do. So I think everything except probably these three, and I don't remember if the video out. I think I have a spare of these because they're the same as on Apple IIs, I'm pretty sure. The Switch, I don't remember if I ordered or not, but I grabbed the DigiKey cart and got everything ordered. So let's put this here, and actually let's look at the website that I'm gonna be using. So here we have AlexTheCat123's Lisa PCBs GitHub repo. Alex the Cat, a wonderful member of the community who reverse engineered these PCBs and is a hero and a saint. Yeah, basically she talks about, so this is about a year old resources here. So she's been reverse engineering some of these PCBs from project because yeah, corrosion damage is a huge problem for these machines. And yeah, so she publishes Gerbers to produce these. These are 2.5 I/O boards, 2.5 motherboards, and the 2-port parallel card. I'm not gonna build a parallel card, but that would be maybe a cool project. And yeah, she tried to make them as authentic as possible, but they're not 100% the same, which I think is fine, personally. She also made a SCSI card, which is cool. I have a SCSI card that's I borrowed from a friend, the community. And let's see here. And this is a fully built board. This is a unpopulated I/O board, that is even. So yeah, you've seen these already. Here are the built things, all put together, very nice and clean. Parallel card. You get 2 parallel ports. So yeah, I guess if you want many printers on your Lisa. Talks about the costs. So yeah, project like this usually sets you back a couple of $100 US, maybe yeah, under 100 to order a bunch of boards, and then $200-300 for components. And here's the key part. So it talks about what you need. And basically, I used this DigiKey card right here. Had to do some substitutions for components that were gone for one reason or another, out of stock somehow. But yeah, this gets you at 90% of the way. It's hard to keep up. So yeah, the 4 components are not available right now. But if you just skip that. Come on. So here we go. By the way, you're all seeing my screen, I hope. Yeah, anyways. So this is all of the parts for the I/O board. $54.20 presently. You also need all of these parts, including the 6504 CPU, which is a coprocessor for I/O, I think, if I'm not mistaken, and some of the rarer logic chips, via stuff like that. These I'm gonna pillage from the original I/O board, so yeah, this is gonna be a destructive process, unfortunately, for that board. And then the COP chip and PROM. I talked about COP earlier. There are ways to emulate the COP board these days, which is awesome, because the COP chips, I did read somewhere that they are infamously susceptible to damage from static electricity, so or some kind of overvoltage. So it's very easy to destroy your COP chips if you are getting static electricity into them. So don't do that because they're very rare. So that's it. But for the I/O board, and then the motherboard, there's another DigiKey card for that. Except the video output jack and the expansion slot connectors. So the expansion slot connectors are apparently an Apple design, so that you have to steal them if you want expansion slots, which is not mandatory, of course. Video jack, I think I have one of those. Oh, let me check my stash. Somewhere. There it is. Oh yeah, the special slot with the weird metal rods. These are perfectly undamaged, so they will be real. Actually, the little edges here are bent on some of them, so but no big deal. They're kind of you lock the card in with these. So these can be real. It's a pain, of course, to desolder these whatever 60 pins or something on each. It's doable, but yeah, you have to be careful not to melt the plastic while you do that. Here's one of my pack boxes of random stuff. Let me just... So yeah, I have already like this little vacuum tube things. I have these are little OLED screens, I think. Micro switches and buzzers and switches. I think I pillaged off some random stuff I was decommissioning, and little switches and replacement gears for Sony floppy drives, automatic eject floppy drive, and barrel connector things, and tiny fan, and here's this is what I'm talking about. This is a composite video port. I got this from I got this in a stash from an eBay seller, I think, when I was repairing an Apple II Plus, actually the one that's sitting on the shelf over there, that had a very corroded composite video slot. So it looks like a perfect match for Lisa. Apple clearly reused that part. So let's put that aside. And yeah, just a bunch of DB25 connectors, and here's a big relay, I think. Funny story, I got this by accident. I ordered from the random eBay seller. I wanted the this is my solder pullet manual desoldering pump, and you have to replace these tips every now and then. So I ordered one of the tips from Amazon, and they sent me this instead. So random. And I complained and got a tip sent out ultimately, and I tried to return this, but my return got returned to me, and the seller was like, whatever, I don't care. So I have a very specific relay sitting around. I don't know. I don't even know what design you would use one of these for. I'm not an electronics I'm not educated in electronics. I'm just an amateur. Excuse me? Getting a phone call. We have some heat sinks. Anyway, maybe I should stop showing you random stuff in my tack box. So hi Zenzai, welcome to the stream. I've been just yammering away for 55 minutes, showing off my Lisa and talking about what I will do rather than actually doing something. So what I have down here, so this is you're a wizard. Well, I'm an amateur wizard, not educated at Hogwarts. Sorry, bad joke. I forgot to mention that for the motherboard. Oh, sorry. Yeah, for the I/O board. In addition to this DigiKey card, there's also an order you need to do make from Jamico or wherever you find old logic chips. So that sits in this CSV file here. So yeah, just a bunch of chips. These are pretty cheap. Not all of them were in stock, unfortunately. I made a note somewhere which ones weren't. They sent me this manila envelope with tubes of chips. Dun, dun, dun. And kind of disconcertingly, here's the invoice. There, I don't know, I'll show it. dumped a bunch of chips floating around there without any kind of protection. I don't know if this is the best way to ship chips. Here's a ROM chip that can be programmed, but yeah, these chips are just floating around in there. Not great. Can my Lisa run a hacked version of Dark Castle? Probably, because it's functionally like a Mac 512K / Mac Plus, something in between there, right? Chips. So if I can give Jamiko some feedback, it would be please put these in tubes or foam or something, right? I think doesn't seem like legs were bent. Oh, there's one bent leg there. But it's less than ideal. Oh, these are pretty bent too. Seems okay. A little bit bent. And that's it. So these are all SP9036. Oh, it's LS157M. So yeah, so LS logic chips of various kinds. This is a Hitachi made 74LS 38P. And Texas Instruments SN47LS 153M, etc. Put them over here. But yeah, one bit. I'm also a huge Dark Castle fan. I'm old enough. When I was a kid, my friend had a hand-me-down Mac Plus that we played on a lot, and Dark Castle was a favorite, of course. We didn't get very far because we were, what, 8-year-old kids, and we're not very good. It's a stupidly hard game, very clunky to control, frankly. But yeah, it's an audio-visual experience for sure. Here, this is the real deal. Look at this packaging. This is DigiKey. DigiKey is a master of packaging. They do an amazing job always. Yeah, rock management. Medium level. So here, these are just long tubes of sockets. Yay, sockets. I'm gonna socket all the ICs because I can. Oh, you beat it in 1988? That's impressive. Yeah, in 1988 I was a wee lad and not very good at action games. Anyway, I was really impressed with DigiKey this time. Look at this ridiculous plastic bag. Oh, just a little rant, I guess, and I guess with a happy ending. The U.S. Postal Service lost this package originally. I had to contact them, and they found it after 2 days and got it delivered to me. In the meantime, I complained to DigiKey as well. Actually, I'm on a pretty tight deadline to finish this project before I have to move. And I asked them very nicely, please, can you perhaps, just in case we don't find that package, can you send me another shipment? And they did. Due to arrive tomorrow. I'll make sure to get it returned to them, unless they want me to keep it. But yeah, great kudos to DigiKey. They are awesome. Definitely my first choice for buying components. the electronic components. Yeah. So there's a bunch of more stuff here. So I don't really have a good methodology in mind to do this. To be honest, I don't think there's a guide beyond looking at the original thing and kind of just putting the right stuff in the right place. So please bear with me. I don't think, excuse me. I don't think there's a step-by-step guide for this. And let's just look at all these baggies, stuff, more sockets. Look at all these little caps. It's gonna be fun. Made in Mexico. Ceramic, 0.1 microfarad, 50 volts, axial. But I think I'm going to try and at least, since the motherboard is fairly simple, let's see if we can find the relevant components earlier than later, and then put them in. Yeah, I wish that was like a dip-in solution for this. On the plus side, this is all through hole, so it's in a way, as an amateur, it's easier to work with through hole than with surface mount. Here we go. So this is this is part of the power supply build I'm going to do another day. So we're lucky enough that these edge connectors, or these sockets, are still in stock here and there. I don't think these are being manufactured. Maybe not anymore. Let me show you. So I was gonna go to the other. So this is the first. This cart was for the I/O board. It's $54.20. Now when we go to the motherboard, you can see the price will come here in a moment. There we go, $96.79. So even though the motherboard is a lot simpler than the I/O board, it's a lot more expensive to build, and that is because of these edge connectors, these sockets, the edge sockets. These 50 position, 50 pin ones cost $12 each, and where's the other one here? Oh, the switch, the little push button for reset costs $12, and the long one, the 120 position. Oh, actually, look at that! It's on back order now, so I bought some of the last ones in stock. Whew. Or maybe because they sent me a second order of the same things. Yeah, sorry about that. $18 each. So those are pricey. Yeah. Last time I bought these on eBay, and that was pretty expensive. So I think my strategy here will be to solder. I think I'm gonna just solder from the middle, add components or assemble components from the inside out. So maybe start with this big cap and then do these sockets. Or actually, it doesn't matter a huge deal just because it's through hole. If this was a surface mount job, yeah, you would want to be very careful about the order. But yeah, I think I'm gonna. So actually, I'm gonna start with the big sockets. I think, just because it's if there is a bunch of components nearby, you don't want to try and hold it. It's easier to use blue tack or something to hold down the connector. And then we need to solder sockets here. I think I'm not gonna solder the ports right away. I'm gonna do that probably. I'm gonna test first and then to the D sub sockets or ports, and I'm probably not gonna do the video out right away, and I'm not gonna do the edge connectors until later. So yeah, let's get these out. Look at these things, chunky and green. And then for these two resistor packs here, that's what, 20? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 20 pin sockets. These are 16 precision. These are much smaller. And these are chips. Let's put the chips over here. These are much, it's a ROM chip sockets. Good. So this video is gonna be me digging through this box a lot. Inductors, they wrap that in an extra bag. Diodes and or the D subs. They always DDQ always does a great job wrapping the D subs in extra bubble wrap. Here are bags in a bigger bag. We got like crystals for clock signals and stuff, transistors and resistors, and caps. Oh, maybe is this the cap for here? 470 microfarads, 35 volt axial. Let's see if that's correct. No, this is 1000 microfarads, 6.3 volts. Low, is that for like TTL logic or something, like very high capacitance and low voltage? I know nothing about electronics, sorry. Oh, here are some sockets. 18 position, so that's not what we need right now. More small bags in a big bag. D subs, transistors, resistors caps, what's it called? Resistor packs. Ceramic, yeah. Oh, sorry, resistor array is what these are called. It's just an array of resistors. Typically, I guess from between pin 1 and the other pins, there's resistance, right? Diodes and caps. Oh, what's this? Resistor array. Oh, yeah, I'm pretty sure these two is what we need for the motherboard. These are the resistor arrays, I'm pretty sure, for the serial ports. They go here and here. Diodes and resistors. Oh, look at this. connector, IC, dip socket, 20 position. Yay, we found them. So let's start with that. Actually, no, these are not the resistor arrays we need here. These are actually thick 16 position. And we need 20 position for this, so we can find them after we solder the sockets. Yeah, they fit in there. And these big, let's see, I think the little holders for pin 1, if I'm not mistaken. So it should go in like this. Let's check what the original has. Right, yeah, so this little hole here is for pin 1. That lines up with that. They're actually, this hole and this hole are different shapes. This is fully circular, and this is elongated. And the silk screen has a kindly the number 1 written there for pin 1. So yeah, finally, an hour 13 minutes in. Let's turn on the soldering iron and the fume extractor. So I don't know if you'll hear a lot of noise, but it's running. And I have some very old blue tack here. I'm gonna see if this still has some elasticity and stickiness to it. Let's just make it, hold that down a little bit. With when you solder this, it's always important to get them flush. Otherwise, you may have problems fitting the expansion of the cards in, or strain relief becomes a problem or something. So I think with this kind of through-hole soldering, I usually don't do any extra flux. I just use the fluxed core on the rosin core. What's it called? Soldering wire. Solder. So yeah, so let's see if we can do this. And after doing the first pin, I like to just try and adjust it, to heat up the solder while pushing in on the connector to make sure it's flush. It looks pretty flush there. Something like that. So it's a good start, just to anchor the whole thing in on both sides. That should give us a good foundation to work on, and now I can take the blue tack off. I'm wondering, maybe I may get a little bit better stability of this if I solder the other one in too. Like so. Because then oh, actually it's pretty wobbly still. Yeah, you saw that. This is why you want to push in on the component, especially a big one like this, while melting the solder, because it was not fully in its position. There you go. Looks pretty flush to me. Anchor it. There we go. Another fun part of soldering 240 pins. Yep, a lot of pins, because you need to, this is the entire CPU address and data and whatever goes through here, and then all the I/O goes through here, so it's just a lot of backs and forths. Jeez, yeah, it's gonna be Final Fantasy first area, right? The tutorial area takes 10 hours. So by the way, I have my iron at 340 degrees Celsius. Rookie mistakes that I made early when learning soldering was, one, to push too hard with the soldering iron onto the PCB and kind of scratching up the PCB, and two was not holding the soldering iron long enough towards the pin and the pad, right? You have to heat both the pin and the pad at the same time, and then apply solder so that both they melt together solidly. So not to be afraid of adding an amount of heat, but yeah, of course, if you're soldering ICs, then you don't want to apply too much heat, because you can damage them. I find a not too generous line of flux helps for long lines like that. Yeah. You mean that you draw a line of flux and then you start soldering? I can try that next. this joint is a bit weak over here. I'm gonna add a little bit more to the ones in the beginning. It looks all right. So another thing that I learned to do was, so you can mix up which components you work on. If you're working in a area for too long, you can overheat. It's no big deal right now, but yeah, you don't want to melt plastics and whatnot. So yeah, it's sometimes it's good to kind of jump over to solder another component, especially if you're working on chips. Oops. Okay. Good thing I have more solder. We'll grab it. There we go. Fresh pack of my favorites, Mandala Crafts solder wire. Yeah, okay, I'll follow your advice. I think the best choice is this flux paste, probably. Something like that. Yeah, I need to get, I don't know, it feels like flux leaves a mess, so there's less, I feel less incentivized to use it. And I think for this job I should probably have used a little thicker wire. I forgot to note, I think this is 0.6 or 8. Yep, I think it's definitely helps with the quality of those joints. And let's flip it around so we can get a good angle. Like so. I always find it ironic that all of these hobbyist type flux that you find are always marketed as no clean flux, right? Whereas in fact, it makes a mess, and sure, you don't, I guess, you don't kill the board if you don't clean it, but it does leave sticky or yeah, otherwise messy residue. I think there is corrosive flux out there. Again, I'm not an expert, but there are types of flux that does corrode the board if you don't clean it off. Just touching up some other joints that I'm seeing here that are a little bit weak. Alright, final row. We're in the final stretch of level 1. And this the solder paste that I'm using here is not too bad when it comes to residue. It's kind of like a somewhat sticky, a little bit viscous liquid that's on there. It comes off pretty easily with just 99% IPA, in my experience. Alright, yeah. The two 120 pin sockets are on here. I think the joints look alright at a glance. I will go over them with a loop before testing, but it seems alright so far. Let's do the toothbrush cleanup here. A lot of alcohol. because this might need a good rinse in distilled water. Sometimes I wonder if Wozniak would sit down with us for whiskey and shooting S and solar our new recreation afterwards. I would find it a waste of his time. It's good. I don't know the Woz that well, but when you watch interviews with him, he seems to be a person that likes to look into the future and innovate rather than linger in the past, so to speak. He's more like a kind of curious technologist who just finds new fun things to tinker with rather than So, but who knows? Maybe he's got a nostalgic age. Oh, made a mistake. So, before you do the full, it's good to remove this blue tack because it melts a little bit of glue residue there. So take this off before you solder everything. Right. So let's get the memory board sockets in there because we need memory to use this computer. Right. Yeah, you're right. I've seen him reminisce for sure. But I read some. I not read, but I saw an interview with him. Forgot what the venue was, and he talked a little bit. I think it was kind of his advice as an engineer, where he was asking people to kind of stay in the forefront and explore the edges of technology, find new ways to do things. Oops, we have actually a bent pin there. These legs are a little bit dull. This is clearly new stock, not recent. So this is where you want to use a lot of flux, I think, to get a good joint. So yeah, there you go. So the socket went in. I wonder though, has anybody seen the Woz talk about his thoughts about the Lisa from a technical perspective? Because that was their rival business unit at the time, right? And as the story goes, the Lisa was designed by committee, right? Business people, product managers, like we call them today. And I don't think it was an engineer's vision behind it, so to speak. Although engineers did build it in the end, and I'm sure they are proud of what it is. Oh, actually, wasn't it the Lisa's? Oh yeah, it's 2023, so the Lisa's 40th birthday earlier this year, and there was a really nice event that I watched the replay on. And yeah, some very passionate and intelligent people who worked on the machine talked about their experience. Okay, that's nice and flush. The other. Make sure to line up the round hole with pin 1. Right. Let's anchor it on the other side. And now for level 2. So pretty quiet night. What are you all up to on this Thursday evening, day, or whatever time you're pulling from? One bit, any cool projects that you've been working on? You're always on the leading edge of, especially programming these old machines. One bit says, I have my third Think C video kind of hanging, but I want to finish it. Procrastinating video on RGB to HDMI from SE30 from start to finish. So, starting projects it's easy, finishing them is hard. But those sounds really cool. You're welcome, Eli. I'm honored to have been the host to Lisa for 2 years or so. So yeah, one bit I still I'm yet to build the same RGB to HDMI solution you did. I have all the parts in another box over there, including the video adapter for the Plus. But yes, just life has been a roller coaster the last 6 months, so haven't really had the energy or time to build those. Also, Brendan, you're saying that you lost the cap for your SE30. You discovered another one was missing. Well, was that a new cap or the old caps? those joints look all right. Let's go for the final row. Thanks again, 1-bit, for the encouragement to use flux. I should always use flux. I'm just, I don't know why. I don't like the mess, so, but I should use flux more. It really bit me actually when I was recapping the Performa 6116 CD with the DOS card. I think the first time around I messed up. Didn't get good joints with a couple of the caps, I think, so the CPU didn't actually work. So I had to redo the joints. So yes, boys and girls, please use flux when you recap your Power Max. I was wondering why I wasn't able to melt any solder, and I realized that. So this is pretty cheap iron that I got from Banggood a couple of years ago, and it's fairly capable. But the biggest problem is that the tips aren't the best fit. It's not a snug fit for this handle, so they kind of slide out a little bit and lose the lose connection inside, and then you don't get any heat anymore. That looks all right. Let's clean up the mess. Oh, you're chatting. Sorry, I'm not keeping up with chats right now. Yeah, it's okay, Eli. I had a good few weeks. You know, I played a bit of Ultima 2 on the Lisa and made a video on that for Reddit, and a lot of people liked it on Reddit, so that was worthwhile. The 12-bit. So what bit you're talking about? The RGB to HDMI, right? Yeah, I think I got the 12-bit variant. Oh yeah, the VT2 Kawari on a C64. That's awesome. You can switch between NTSC and PAL on the run. That's kind of a dream come true. As somebody who grew up in PAL land, you know, getting access to NTC software is a dream. Alright, so let's clean up. Thanks for sharing some history on the Lisa, Eli. It is a very, I think you were interacting with some very cool people back then who liked to use Lisas, when Lisas were definitely not in vogue, so to speak. Yeah, this is gross. Yeah, I guess 1-bit, you're right. When it came to C64, I guess PAL had a lot of cool stuff. Like one of my favorites from the. So my best friend and neighbor had a C64 that he got from an uncle, and One of the most mind-blowing pieces of software games I played on that was the Armor of Antiriad, which is like a action-adventure Metroidvania, I guess you would call it these days. Kind of screen-based action platformer where you traverse terrain and get upgrades. Eventually you get the sacred armor of Antiriad, which allows you to fly and shoot laser beams and explore a maze that's kind of on the top of the map. And just the act of gradually exploring that world that kind of opens up more and more, and upgrading your character and overcoming obstacles and finding secrets. It was just mind blowing as a 7-year-old kid, and that was a British game. I think it was made by a UK studio, and it may have gotten an NTSC release, but it was kind of like a hacked version of PAL game, and it probably didn't get much traction in North America. But it was an absolute. It's hard to play these games. It's kind of like Dark Castle in that it's actually kind of similar because before you get your suit, you have to fight with rocks, and the rocks have a very distinct trajectory, and it's just really hard to fight enemies with it. And it's kind of this old school UK game design of these kind of respawning monsters that are very aggressive on each screen. It's hard to play these days, but it's very, very, very cool. Yeah, the Sacred Armor of Antiriad. I'm pretty sure that's the name of it. It's super cool. Some other point I was going to make, but I forgot. Alright, so let's see. We should get the sockets in for the sister packs. So you want to, of course, when you get IC sockets, you want to make sure that the little notch on the socket line up with the notch on the suit screen. Oh yeah, Super Meat Boy is probably one of my favorite games of all time. I played that so much when it came out on Xbox 360, or it's called the arcade, Summer of Arcade, something or another. And yeah, it's one of my. I did most of that game, and I didn't beat the final boss because it was annoying. It's so good. So it's funny when we talk about the games on these systems. One of my original visions for this channel was to have more kind of playing games or playing with software content. But I just keep ending up fixing up old Apple hardware instead. It's kind of it's been kind of limited how much time I've been able to spend. Do you all think software content would be more interesting than soldering content? I don't know what you're all looking for in a channel like this. That's a good point. 1 bit. You need to fix stuff. You need to fix the hardware before the software can run. But I had this weird cycle where I get some hardware in need of fixing, and then I fix it, and then I kind of move on to fixing something else instead of actually playing too much with it. Focusing on software puts you in the clear minority. Yeah, yeah, that's the thing. Yeah, the soldering and electronics fixing channels are it's probably red ocean, right? A lot of really talented people out there. Yeah, it's a good point. MK500. Yeah, just figuring out what's wrong with these things is it's very rewarding. You know, you bring something to life that was dead and can be used and enjoyed again by you or someone else. And so yeah, I'm relocating internationally quite soon, and I've been selling off a lot of my computers that I fixed, and it always feels gratifying to hand off to somebody, you know, a working piece of hardware that wasn't working before, and they are, you know, really appreciative of being able to play with old machines. That's really cool. So it's funny. One of the reasons I got it back into old Macs a couple of years ago was I just randomly started thinking of old Mac software from the like early 90s and so on. And I looked on YouTube for content, and this is almost like maybe 8 years ago. Looking for contents of, you know, somebody filming old Mac software and sharing it on YouTube, and were quite rare at the time, especially. And I find this guy called Tamara Kudorov, I think his name is. Um, Canadian or American, I'm not sure. Who did a bunch of content on old Mac software, and kind of he had pretty cool delivery style, and I really liked his content, and I think he still does sometimes. So that I just appreciated him putting together this, you know, showing off all this old software. Okay, so actually we have this is a 1, 2, 3, 4, 5, 6, 7, 14 position LS132 chip that needs to go here. But actually, let's do that later. Let's get the resistors and the caps and stuff in. Yeah, I found the 14. Let's get this off again too. Fourteen pins socket for this spot right here. This board is getting mighty sticky. It will need a full bath, probably in distilled water at some point. So I think in order to make you know, actually efficient content like this, I will have to need to sort these components. I think I'm planning to wrap up this stream shortly, because otherwise this is, I think, to find all the resistors and mostly and capacitors and everything. There's gonna be a lot of me digging around in these boxes. So, what's this? Oh, here we go. This is 1000 microfarad, 16 volts. Oh yeah, thanks that 1bit. Always good to have you on the stream. You're a friend of the channel, and also you should all check out 1bit's channel because it's awesome. He has a ton of amazing content, especially on the software and programming side of black and white Macs. So it's great. So I think this is the cap that goes right here. It's not a 6.3 volt, but it's a 16 volt. I think in 99.9% of cases you can always go higher on the voltage for electrolytic caps. Let me double check on the shopping cart to make sure that that cap is not meant for some other purpose somewhere else. 1000 microfarad. Just the one. Yep, it's only the 1000 microfarad cap, so there's no other place it goes than right in here. I like these axial caps. I want to make sure that the ratings are what specifications are visible from. So I want to make sure it points outwards. And that's you'll know. These arrows here point towards negative on axial caps, so it goes right in here. So as I mentioned, I intend to wrap this project up in probably about a week, so unless something unforeseen happens, I intend to do these streams fairly frequently for a while. So would like to see how this project turns out. Don't hesitate to hit that subscribe button, of course, and the little alert so you can see when I schedule one of these. And I think I've gotten a bit better at scheduling these. Before in the beginning, I was like, oh, I want to stream in 10 minutes, and then I put something up, and then nobody watches it. So I learned to try and plan ahead a little bit, at least. And I think that's helped. I think I definitely see more of you all interacting in chat. So that's cool. Yeah, it's starting to look like an Elisa motherboard now. The outlines are here, big chunky connectors, the distinct cap in the middle, the little IC sockets. Now we just need this row of resistors here, and two transistors, I think these two. And then we need some resistors over here, caps. One electric cap here. These inductors, I think these are here, are probably not. They're for the mouse. I'm pretty sure it's kind of. I think they needed some extra protection for this. I think the mouse is sending very rapid signals into the bus, so they just have a bunch of inductors to smooth that out. Unless I'm mistaken. And then we should be good to test this. I don't think we don't need the DB ports. We don't need the video out. We don't need the probably maybe the reset switch is good to have. Yeah, so I'll probably stream again tomorrow unless something unforeseen happen. I will have all the components sorted out nicely so I can make rapid progress, and we should get to a state of testing the motherboard. So thanks you all so much for watching and chatting and interacting. So I appreciate you all so very, very much. Have a great rest of your day or night or evening, and see you all next time.